Hello and welcome everyone to another DBA Masterclass. My name is Osama Ahmad, and I am a database business development leader in EMEA Tech Software. Today, we will have another session as part of our journey with 23 AI. We started this journey several months back, and in April, we covered the new 23 AI features for Oracle scalability, high availability, and disaster recovery. However, we also wanted to have a drill down on individual availability solutions, and therefore we talked about Data Garden 23i in the last DB Master class, and today we will address Oracle 23AI real application clusters and application continuity. And in order to provide this insight, I'm joined today by Anil Nair, our product manager for Mission Critical Database, who covers Oracle RAC. And in order to answer your questions, I'm joined by our panelists, Sebastian from the product team of Mission Critical Database, and also by Stefan from the EMEA Database Specialist team. So if you have any questions along the way, then please post them in the Q&A window, and the team will take care of answering them. And as a quick reminder, one of the available channels for you to stay up to date on the DBA Master classes is our LinkedIn group. So if you have not done this already, you are most welcome to join us. And here's a list of resources that we will be sharing with you today that will allow you to gain more insight on the solutions. So you can go through them after the session is over. And now I'm going to hand over to Anil. Anil, over to you.
Great. Thank you, Osama. I'm just going to share my screen in 1 second. Share. And hopefully you guys can see my screen. All right.
Yes, we can.
Great. All right, so let's start. I think, thank you first of all, Osama, for giving me a chance to come and give this session. I didn't know it was the last one of the year, so hey, we should be doing a lot more and giving you a lot more information to everybody. I'm Anil Nair, by the way, for those if you missed the starting part. I'm the product manager for ASM, RAC, AC, and I'm joined by Sebastian and Stefan to help me go through the session. So if you have any questions that I talk about any slide, please put that in the Q&A, and Sebastian or Stefan will answer that. A lot of the concepts I'm going to talk about, I have set up some of those, I talked about a bit earlier. So there would be some, blogs or URLs that would be there in my LinkedIn. So, definitely go look at that URL. So what we're going to talk about today is, what is some of the things that are relevant as tips and tricks to maximize your uptime. And obviously the solution includes RAC and app continuity. So a typical DBA nightmare, right? Or a developer nightmare, it doesn't matter. Hey, application is not working, some 404 error. Well, this application developer is actually very good in the sense, at least he put that error. I've noticed recently a big bank which could not access the database and so showed all the accounts as zero. That's even more scarier, right? So it's the worst thing that could happen. We don't know what is the problem. Is it a database issue? Is that a performance issue? Is that a network something? We don't know what happened. And one of the things that we look at when we are talking about HA for the app, and which is end-to-end, it doesn't matter if it's the server or the OS, it's the database, or if it's performance, or is it some application reaction time. I mean, sometimes application can get hung because of bugs in the application code. What we need is a solution that can provide or take care of all of these different layers or architectural layers and make sure that we are protected. So for the left two, as in I call it the database and the server, we have some, Oracle Real Application Clusters does a fantastic job of not only detecting the problem, but also resolving the problem. And on the right-hand side is what we call as application continuity or transparent application continuity. So we're going to talk about the next sections of the talk will be divided into some of these layers, and we'll talk about how these are built, or such that it seamlessly integrates into your application in your environment, regardless whether you're on the Oracle Cloud or you're on premises. It works perfect. So why RAC? The why part is very important because this is the only solution which is providing like active instances. Active is very important because when there is a problem, you need somewhere else to go to and be able to get that data. And you don't want it like, oh, host one, if host one is failing, I'll go to host two. That is a delay. The other part that we want to do is, does that work and, take care of different kinds of application? Yes, we take care of different kinds of application workload. We should be fine. What about, support? Simply put, hey, if it works on single instance, it's supported on RAC. And what the final thing is, what happens during, if I have an application issue or I need to apply some patch, or which is called as planned maintenance? Well, again, because it's multi-instance, I could go from 1 to 2 or 2 to 3, either during a planned outage, what I call planned maintenance, which is essentially like a operating system patching or some physical hardware issue, or you could go through what we call as app continuity during an unplanned outage. And we'll talk about a lot more about application continuity at the end of the time. More importantly is that the one thing that people tell me is, Anil, we have this VM failover things that work similarly. Well, VM failover things are not exactly the same because you fail the VM, the application doesn't fail in that. So here we have an entire package. So as a developer, as a DBA, once your application is deployed in operations, typically that's what happens. The operations folks do not even have to get into this VM migration, then move the application one by one or database one by one. It all is taken care of by RAC. Now for RAC, one of the biggest things why I say why RAC is because you have to understand what impacts availability. As a human being, we understand that, oh, if my cell is not able to make a call, either I have like no coverage, I can check things out. But as a computer or as a program or as a entity or a process or a daemon, it's not very easy to find out, hey, is it a CPU issue or is it some swapping that happened? So it kind of just there is a issue. That's all the process knows, and especially processes that run in what I call as user land. And also when you have planned maintenance, the process doesn't know it's a planned maintenance, right? So when you say, hey, I'm shutting down my database, you're shutting your database for your backup or you're shutting down your database for moving the data somewhere else, it doesn't matter. What matters is that for each of these issues, like whether it's a network cut as shown in the diagram or if there's a whole site-wide outage, what do we do is very important. And the last point is extremely important there, which is to contain the blast radius. So if there is hey, my application doesn't work and everybody's scrambling to find out, hey, is it a server issue, performance issue, this, that, it's already too late. We need an automated mechanism to do it. And then people say, no, cloud takes care of all of these things. Well, similar problem exists in the cloud. Cloud provides the infrastructure. You still need a sophisticated set of databases and things like app continuity to make sure that individual outages are not seen by the application. Right? Now, when you say the blast radius, we also don't want to take the entire server down or the site down when it's a problem is isolated to a CPU. It's extremely important because what happens is the more the blast radius, the more the impact. So you don't want people randomly pulling out network cables or trying to put network cables or having different kinds of storage issues, trying to do different things. The worst thing is you do not contain the blast radius, you would be completely down. Let's say your issue was on one server in a 4-node cluster, failing over to standby. Yes, but is that worth it? Because all your applications are now going to the other side. Now you need to plan to get it back. You need to recreate the standby. There's a lot of things that could go wrong. That is in what I call as too much reaction to what the issue is. So, today we're going to talk about and focus about certain high availability features, and I've kind of highlighted them somewhere around. And mainly, we're not going to talk about 11G and all that, but we're trying to talk more about, 21, sorry, 19. Of course, that's features for now 21, which are backported now into 19, and then 23. We are going to talk about some of the features. Some of them have been backported to 19, and I'll, touch on that. So, you know, as I said, this is not like hey, we wrote the entire code for in one database release, right? We have been building up on some of these features, and we are making them more and more pointed towards the current hardware, the current software, and the current needs, and they all work together such seamlessly so that you don't have to go and configure things, right? So understand our clusterware architecture that has not changed for a while. We still have, whether it's a check config or init mechanisms, we still have a mechanism to start up when the operating system boots up. One of the things I kind of highlight with this is, hey, it's very important to know how or what starts which process, right? Why? Because as a tip, number one tip is like when some resource is not started, let's say a scan resource is not started, or let's say a database is not started, how do you figure out which trace file to look at? Well, look at this hierarchy. So you know that OHASD, which starts the CSSD agent. So CSSD agent would be taking care of a resource called ora.cssd. And so now you know how that process is being or entity is being maintained. Is it through a ora root agent or an ora agent? Is it the ora agent for the CRS user or the ora agent for the RAC user? And the implication being the database user and the owner of the infrastructure. So in 23 AI, we used to have CSSD as the only entity that monitors what we call as health membership and health of the node and node membership. In 23, we have kind of moved out to something called as ONMD. Now, the ONMD is kind of like breaking out from the OCSSD. So it is doing the what we call as the network heartbeat and the disk heartbeat, and then we have talked about this for a long time, right? The network heartbeat is the what we have identified as a private network, and we send and receive heartbeat messages, and then we have this idea of that if you don't send me messages over a certain amount of time, we're going to do something called as eviction. Transient issues like, hey, if I lose one packet here and there, we are not necessarily considering that fatal. I would say, hey, one packet lost. Come on, Anil. Remember, this is a private network. And lately, if you know that the networking, what we call as area is getting much and more sophisticated, right? There's no more like, typical loss of packets and stuff. So if you have a very good, well-defined, operations, you should not see much of, lost packets. Then we have the backup mechanism, which we call it as a disk heartbeat. That is for a network split resolution. Because think of it, if two nodes can't talk to each other, how can you tell the other guy to be evicted, right? So you have something called as a disk heartbeat, and we have something called a short I/O timeout and long I/O timeout. And I've talked about this in the past. I'm not going to get into this much, but what I'm going to try to get into is more about the ONMD. Now, ONMD is the one that does what we call as the network heartbeats, and right, is responsible for writing the kill block and all that. So when you're having a node eviction or when some issue is occurring on a private network, you want to look at the ONMD trace file to find out what happened. Obviously, you start with the GI alert log, which will have all the information, which will point you to the right file. But that's another way to look at is you figure out that it's a network thing. So you'd be like, Anil, so what does OCSSD do? Well, OCSSD, and the reason why we split this out is because OCSSD takes care of what we call as the group membership services and all that. The reason this was separated out is because initially ONMD was another thread in the CSSD daemon. The reason it was split out is because now with this more targeted breakup of these processes such that ONMD, which monitors the network, and CSSDs, that CSSD is now more highly available. What I mean by that is if there is a group membership issue or something, now CSSD could actually work with the peer CSSDs and recreate the information so that it doesn't need to restart it for that. So as you can see, we're trying more and more to reduce your chances of downtime. So if there are those corner cases where the nodes of the cluster differ on the group membership services, they have time to figure it out. They don't need to be like immediately taken care of by evicting the node or going or crashing. So that's one of the reasons why we have ONMD. Now remember I talked about the blast radius. So let's say you have, a a 4-node cluster, and you have a what we call as a split brain, right? Now you have 1, 2, 3, 4. If you look count from the left-hand side to the right-hand side, typically Oracle cluster were always used to evict the third and fourth node. But here we have a mechanism by which what we call as node weighting, which kind of will make sure that the more the services, the more the chance that the side of the cluster which has more services will survive. What does that mean in this case? If you count, there are 3 services on node 3 and 4. There are 2 services node 1 and 2. So we kind of make sure that we only take down the side of the cluster or the side of the subcluster which is having lesser work. So the idea is, hey, if everything else is equal, let the majority of the work survive. What does everything equal mean? You have to have an equal number of nodes distributed in that, on both sides of the subcluster. Now, this is yet another example of how what we make sure that we dramatically reduce the blast radius. So now you're saying, what happens if there's another issue? Like, let's say if there is some kind of public network issue. Well, then we come back and we will keep the left side of the cluster because it has the public network up. Again, we want to make sure majority of the work survive, because it doesn't matter if the node is up, but the public network is down, which means the database clients cannot reach it, then we take care of it. Well, what's the worst case scenario? What happens if if it's equal number and the public network is down everywhere? Well, then we just fall back to our previous thing, which is basically we say, hey, I don't think I know enough what to do. I'm just going to let 1 and 2 be available because that's the best I know. Now you'd say, hey, no, what happens if my operations people know what to do? I think we have a better way, or we have a database that we think is very, very important. So then we also give you an option where say, hey, you can customize your node weighting. You can set CRSCTL, set server 1 or set server node 1, 2, or whatever to be critical. You want to not put it on all the nodes. You want to put it on one node or a depict of 1 or 2 nodes, depending on how many nodes you have in the cluster. And during an eviction, we will say, hey, I think more work is on node number 3 and 4, but the DBA and operations or whoever has marked 1 and 2. So I'm going to put 1 as there. And similarly for database, you can say servctl modify database minus CSS critical, which means wherever the database service is running, we'll try to maintain that, right? So all of that we try to do, and obviously this is an option that you could do manually. Rest is all automatic, right? Now, once we have everything up and running, now what do we do to make sure that the resource is up? Remember, we want to make sure that the database is up and running, and then everything is a resource. A database is a resource, an instance is a resource, a disk group is a resource, a scan is a resource. So scan is a process, and we also maintain what we call as state information in what we call as resource. So we try to make sure all of these are monitored and measured. So during startup, everything has an agent in the sense that CSS has an agent, CRSD, we all have, these are all managed and monitored to make sure that the resource that they're monitoring is taken care of. And these are what we call as persistent threaded processes. We're optimized for performance. What that means is a lot of the code is reused so that the spawning, it doesn't matter whether you want to start a database or a listener, right? The start is spawned. So we have a lot of these threaded resources optimized for performance. We also do not just regular checks. So what I mean by that is, for databases, right? If you try to write your own monitoring script, you would say, hey, let me look at PS minus EF grep awk minus, and print PMON. If PMON is up, I'm good. Well, there are a lot of times when PMON could be up, but the database could still be hung. So we have what we call as regular checks and what we have called as database specific GIMH checks, where we look in the particular area in the SGA to make sure there is SCNs are progressing. If SCNs are not progressing, that's like, oh, something is wrong, right? Because the database, which is active, will move much faster in terms of incrementing GIMH. We have CSSD monitor and agent, which monitors both the ONMD and CSSD. So what happens is if CSS, which runs, by the way, as the GI user, if it doesn't get scheduled, we monitor it, which the idea being that, hey, if you can't even do a local heartbeat to your own CSS monitor, then there's something wrong. The node is not deemed sick, not deemed healthy, and we could take care of something. We also make sure that if they are stuck in some weird kernel call or whatever, we have ways by which we can know what's going on. Right. Now we have this thing called we have security in the sense that if you have different kinds of users, let's say you have database user as 1 and 2 and 3, we'll have 3 different processes for that. And obviously, the way you have to understand that is everything is all the agents obviously have agent in the trace file. You have an Aura agent, Aura root agent. So logic typically says that the root resources like the network would be taken care of by something like the Aura root agent. The database specific ones will be the Aura agent. And so Aura agent underscore user one would be what would be the agent process and the subsequent agent trace file for that. So I gave the format that so that you can understand that, and then gives an example like, okay, if you want to find out that, hey, something's happening to my listener, how do I find out? Well, you could find out using that logic, which is basically that it will be CRSD Aura agent CRS user, because remember, the listener is in the GI network admin directory, because that's where we want to keep it. We don't want to have individual entries for every database home. So there is things that we logic that you have to use to find out which agent file would have which resource information. The state of the resource. Yeah, when you do CRS-CTL stat res minus t, you would have one of these states. Obviously, the good ones is all online, and then you have unplanned offline, which is bad. Planned offline, which is because you're applying something and you made it a point to stop something, and all the rest. Now you'd say, Anil, what happens if there's something called unplanned offline? Well, we need to find out what happened. So in this case, I've given an example of an agent trace file, which tells you that, hey, this CVU ADM or resource, I changed the start from offline to starting. It could be starting to offline. It could be one of those things. But that's one of the things to you to look at. Like, go to the agent trace file, look at what is changing state. And then once you find out that there's something called the GUID that I've highlighted, that things in the curly brackets that you have, the idea is that, remember, there are multiple agents that take care of the resource. Then the resource itself has its own trace file, right? For example, let's say a database would have its own alert log. The CVU would have its own log. So how do you map these multiple things? Well, this GUIDs will make it easier to find out that, oh, this happened. And so if I use this entity, I can go to the other trace file or other log file and look at what happened at that time, because I don't need to look at the specific times, because remember, these are threaded. What would happen is in between these threads, you would have, hey, here's a ping from CVU, here's a ping from database, here's a ping from something else. So you don't have to try to go through this in a serial fashion. And by the way, a lot of these things are automated. When you look at, for example, when you have a SR open and you upload all these trace files, internally we have tools by which we can map these things far more quicker, so that we can understand what happened or what is the high level idea. And this is using this GUID. Similarly with the HAIP and network management. Now, if you ask me, I used to be in support for the longest time. And if you ask me, hey, Anil, what is the one thing that you think is the biggest problem for RAC or bothers RAC, which is, I keep saying, hey, network, private network. Even today, I would not change much, private network or lack of CPU. The problem is we blame the network. Yeah, it's always a network issue. But sometimes it's just the fact that there is no CPU left on the server, so that the process is actually having the packets in the network buffer, but the process is not scheduled to go and get that packet. So, regardless of the fact we have a lot of this infrastructure built out to protect our networks. So we have this HAIP for the longest time. And, I talked about HAIP, so I'm not going to get into much of details. There are three things that perhaps I need to reiterate. HAIP is what I call as, like a bonding solution or a non-platform specific bonding solution. What we do is there's a process called gypcd. gypcd is the one that takes care of it. The good thing is we have optimized it. So remember, we have the CSS, ONMD heartbeats, and I keep saying CSS, sorry, but it's ONMD heartbeats. We piggyback on top of that so that we can, we don't have to like send separate messages on top of that. So we kind of piggyback, which means that if I can't read something, I know that the network is bad. And this is the information that you'd see in a typical gypcd trace file. And it says, hey, there is some rank that we give. A rank is basically the higher the rank, the more better the network. So if the rank goes bad, then we'll say, hey, the network is bad, and we will kind of take care of that entire network path. That way, we'll make sure that it's available. And here you can see in the bottom right side that we actually use what we call as the functionality of CTSS to make sure the gypcd is periodically running. So we can see that it has a heartbeat to the gypcd daemon and say, hey, what's the last time you did the heartbeat? You have to periodically check with me. So the idea is that we want to react quickly if there's a network issue. Again, remember the idea of containing the blast radius. If there's a network issue, if you have two networks defined for private network, if one is having a problem, the other one should be okay. So we don't want to like take the entire node down or instances down. Moving on, we have something called as the new NMON process in 23 AI. So from a database side, we have this NMON process, which also now dumps database specific information in terms of, it basically invokes the nstat minus az and other OS commands, but internally tries to keep a track of all the typical IP statistics. So this can be used to find out if LMS is not able to send something, or even a data guard on a public network is not able to send something to the standby site. We can now have this NMON process. So we don't have to go and look at, this network timed out or send timed out. We don't have to go and look at OS Watcher. Well, we could look at OS Watcher, but here we have an integrated solution which takes care of all these different entities and make sure that we have the data we want. Taking it a step further, database reliability framework. This is one of my favorite features that came out in 12.2. We improved that in 19, and now we even made it better in 23. The other favorite feature, which is DRM. Well, in a way, yes, because as I keep saying, when DRM works, nobody cares, and it works 99.99% of the time. The 1% or even 0.1% time it has a problem, everybody gets upset about it, which is true. Definitely true. I'm not complaining. I'm just saying that we're making it better. So we have done a lot of work to disable DRM during periods of high CPU. So database reliability framework is the entity that lets this decision making be automated. What happens if there is a CPU or less CPU? Well, what happens if GCR blocks are congested? So what is the one primary reason for block congestion? Well, lack of CPU. It looks like, hey, the network is not big enough, so we are trying to send too much across. Well, that never happens, because remember, networks nowadays have a lot of bandwidth. Its latency is as low as possible. Typically, what we have seen is congestion issues is because LMS is not able to be scheduled, or either the communication between the LMS and the user foreground process is slow or whatever. Which means what? CPU. Well, if GCCR process block is congested, do you really want to do DRM at that time? Not really. So we take a back seat and say, you know what? let it go. In 23, we are even doing a lot more in terms of these things, and trying to reduce this. So again, remember, the idea is to monitor, make minor changes so that the customer at the end, the database process at the end, does not feel or get impacted by that. And finally, yes, this is yet another thing that is so unique with RAC, which is basically what I call as the hang manager, or as we call as the blocker resolver in 23. Well, the name changes because the hang manager name was not deemed very good, so we kind of moved it to blocker resolver. The idea is simple. We want to detect and resolve hangs. When I keep, I used to have this, flow chart, and it's like 3 sessions. No, not really three. There are literally thousands of sessions. I know in certain, of our autonomous offerings, there are literally thousands and thousands of sessions. I know one customer I was looking at the other day, there are 10,000 sessions. Now think of it. Now you have to figure out as a hang when you have 5,000 sessions. This is really, really smart. If you look at the amount of CPU that the DIAG or DIA0 processes use, they are literally nothing. What we do is we first take all these sessions. We don't need to go through each of them because we need to just find out the one that are waiting for a resource. So if you have a user process that says, hey, I'm waiting for insert into EMP table, so lock for that, we'll know, oh yeah, you're waiting. So out of the 5,000, let's say 200 are waiting for some resource. Then we find out, hey, what's the final holder doing? Is the final holder actually moving? If it's moving, just ignore it because it's just normal processing. If it's not moving, we want to do something. We're going to find out what is it. Is it a background process? Is it a cross-boundary hang? A cross-boundary hang is basically a hang in the database because it's waiting for something on the ASM layer, or it could be even like across nodes. Obviously, it works for a long time. And then finally, we need to decide, what do we do now? Do we do like kill that process? Well, if it's a fatal process, it takes a scope of instance level, and we have a choice by which customers could also set it up to node level, which means hang manager will try to take care of the instance level. If it doesn't work, we'll escalate to a node level. So there are a lot of these things that are there. Now in 23 AI, obviously we can do a little bit more better because now we can actually, we have some optimizations where we can fast track the final blocker. Now what does this mean? So let's say there's a final blocker who's of impacting, like say, X% of all the weights. So if you have, like say, literally, to take your example, 5,000 total users, 200 users are on waiting, and the holder is one person, which holding 200. So if you look at it as a percentage wise, that's a really big percentage. So then we can, okay, you know what? We should fast track this because it's impacting a lot more sessions. So we do all that internally. I would say, Anil, I don't like the typical normal, which is the sensitivity of how quickly hang manager should do, because remember, it's a thankless job in the sense that if you take care of these things too quickly, you'll say, hey, why is Oracle database killing my sessions? If you do it too late, it's like, hey, my process is stuck. So we kind of give you a default, which is normal. And if you think, I need to make it really more sensitive, you can set it up. And you can set it up to high. And that is the procedure to do that. I wouldn't do it without testing, but you want to make sure that you take care of that. Now, how do you look at these things? So you would get these errors as ORA 32701, and we would tell you that, hey, this is the trace file, this is what happened, and I did this. So I terminated the process because it was affecting a significant number of sessions. Again, remember, we're trying to reduce the blast radius. If something is hung, the application is hung, we don't want to go and reboot the server and evict or kill the instance. We want to make sure that we target that piece, a precision strike to that process rather than taking the entire instance down. In 19 and pre-19, what we did, we had this other problem which we isolated what we call as the hash resources. So what that means is before 19C, if you look at the alert log or the Elm trace file, everything is the resource hash table would have the PDB's resources split across equally. So you would see that, hey, certain hash tables would have the red PDB, the blue PDB, and the green PDB. The problem is that when you need to do some kind of recovery of this hash table, you cannot let any of those PDBs move ahead until you have looked at all these hash tables. So what we have done in 19C is we have kind of spread it out. So a hash table is no longer just hanging off a single domain. We have multiple domains. For every PDB, we have a domain. That means that if an instance is not open on node 3 and node 3 crashes, we can actually don't even worry about that because for PDB3, because the PDB is not open on that instance, which means there's no resources on that table. We don't need to look at the hash table for those PDB because we know that it's not there. So we kind of optimized it such that this isolation makes it more available. Now, this is something that is really good. Now you'd say, okay, Anil, you did all these great things for the issues. Now, what happened during plant maintenance? Well, plant maintenance, Oracle has been having this, so many ways by which we reduce the impact. So forget about app continuity. We even try to apply GI patches without taking down the database, right? Now, yeah, we've been promising that for a long time. In 12.2, in 19, we have certain RU after which we allow you to do GI patching without taking instances down. In 23, we'll have a more broader rollout. So remember that ONMD part that I talked about? That is one of the important changes that came along that makes it easier to do it. Because what happens is when you try to apply a patch when the GI, your database is up, GI is down, the group membership is the one that is possibly the most important thing. And if the peers do not agree on the thing, then we need to take it down. Well, this ONMD optimization helps here. So you can now say apply the GI patches without even interrupting databases. In 23, we have this other two features, which is called as the local rolling database maintenance. So the other problem that customers mentioned is, hey, I have this really big server and I have VMs that I can resize anytime I want. Can you make it easier for me to reduce my impact? Well, we still have app continuity, we still have rolling. So what we've done is we allow you to basically, create a new instance on the same node so that you can easily move the work. So just by two commands, servctl modify database, you can move the work from instance 1 to instance 5 on the same node. The instance 1 shuts down, and then you can resize your VM back to what it was. So this is yet another option that we do to customers to make sure that they can apply patches without impacting your applications. Now, your application doesn't change. It's still continuing on. The scan will make sure that things will go on, and all of these things can be done seamlessly. And again, you repeat them into instance 2, instance 3, and then you move on, and then you're done your application of the patch, right? The second one that we have is two-stage rolling patching. So two-stage rolling patching is one of the things we actually have periodic meetings because certain patches cannot be applied in a rolling fashion. We have to figure out how to get customers that patch. Customers don't like taking downtime. And the more complicated is, this is until then now provided as a one-off, which means you have to apply RU and then you apply one-off and then all that. This two-stage rolling patching will essentially allow you to apply patches which were previously deemed non-rolling. What we do is basically we do the update, we apply the patch. Again, if you look at the version number, we have not enabled the patch. Once the last node we apply the patch, we enable the patch. That means all those changes can be done in one shot. So this significantly reduces the customer downtime, which makes an application be more available, right? So that's the most important idea. I've talked about RAC reconfig. So anytime you have a node or instance crash, this happens regardless of our best intentions. We want to make sure that we start immediately. And remember, till 19, we used to do it as fast as possible. Some numbers that I saw is less than 3 seconds and all that, in sense of how much time it takes for a large buffer cache to be, going through what we call as a reconfiguration process. So now what we've done in 23 is that the reconfiguration time we know is something. Once the instance crashes to when the instance is up and ready is what we call as a reconfiguration time. In 23, we have dramatically reduced that. The reason we have reduced, and I'll talk about it in specific timings, is that we now allow work to start 6x times faster, and our recovery time is recovery time is within 3/4 of the time. So what makes this faster? There's a feature called FSR, which is fast start reconfiguration. So there are a couple of optimizations that we have done. Remember, what we do internally is that there are blocks. So the larger the SGA, the more the blocks that are there in the SGA. The good thing is the blocks could be in two states. Either they are good or what we call as dubious. Dubious means we don't know. Don't know means whether the blocks need to be written to disk or whether they need to be rolled back for committed non-committed transactions. So whenever this happens, we need to start looking at these blocks. Now there are a bunch of features that helped in this. We have something called as Recovery Buddy that helped in 19C to optimize some of these processes. And again, I've talked about Recovery Buddy in the past. You can look at that in my previous talks. I'm not going to spend time on that. What I'm going to spend time on is this, that we have this fast tracking. Fast tracking means that if some waiter of a resource is waiting on a resource, and let's say these buckets and buckets of blocks that we are looking at for dubious, we kind of say, hey, somebody's waiting on this, let's prioritize a certain bucket. So it could be that, let's say you have an EMP table block or a department table block. The department table is not in use as much. So if somebody is waiting on an EMP table block, we'll be fast tracking that immediately. We also use what we call as Bloom filters to apply this faster. So a bunch of those optimizations help this go faster. And so now we are able to do it so much faster that in most cases, customers don't even see an impact on that. Again, I say in most cases because there are a lot of things going on around it. So typically, we try to even reduce the impact, or in fact, there's no impact on that. We've automatically, tried to restart things, and try to not get, have downtime. For example, we monitor resources and say, start something. If it failed, we restart it. We try to fix things in the back end. So we have done a lot of these things. And again, we want to make sure we autocorrect the resource state without trying to take a downtime. Right. So now that we talked about all that, great, the database is good and up and running. Hey, but what good is the database up and running if my clients are still stuck? Remember, I still can't connect. I had this big problem back in the day. So now we have something called AC and TAC, what we call as our unique solution that works with RAC and Active Data Guard. So we can use it across your disaster recovery sites too. So let's get into what is AC and TAC. Just because certain developers are not very clear about it, I know the database folks, DBAs know very well, but let's set the context. In Oracle RAC, what happens is connections come through, whether they come through directly or whether they come through a pool, it doesn't matter. We have something as an entity called as the scan. The scan talks to the database, and we have all these mechanisms. We have something called as ONS. The ONS is essentially a notification mechanism, which is depicted by the bell icons. And so this is how a connection works. Now, what happens is, okay, that's a good case. Now, what happened in a bad case? In a bad case, what happens is, let's say a connection comes in from the user and it goes to the client access network. If there is a instance issue or a public network issue at the time, without this, we would just wait for TCP timeout. But what happens is behind the scene, the GI does this, invokes this gratuitous ARP, which updates the ARP table, which means this session gets an instant error instead of what we call as waiting on TCP timeout. And then it can actually go and retry the connection. And then we send the event up saying, hey, don't even try to send people to node number 1, it's down. So we not only figure out the issue, we kind of propagate that information right up to the the end user or the connection pool. Great, this has been there for a long time. So what's so special? The special part is that we absolve the application developer from writing complex retry logic. So if you look at it here, and this is taken from a typical open source project, you get this, hey, if the status code is 500 and wait for five times and sleep for 5 seconds, things are not that, you don't want to hard code these things. And there are different kinds of application errors which require different kinds of retries and timeouts. So you don't want to do this. You want to make sure that the application developer just focuses on the business logic and then the database manage failover and replay. So now that we have established that the application can connect to the database, can take care of failover if there's a particular instance issue, let's go a step further. Let's try to get end-to-end protection from outages rather than just failover. So instead of waiting, getting an error, or needing to reconnect, which we have done all that now, needing to restart. Now, yes, you reconnected back to another instance. Now, what do? I had two inserts into my table saying, hey, insert into EMP, increase employee ID Anil's salary by 10%, and I committed that. What do I do when I fail over? I did not get acknowledgement. What should I do? How do I continue off? That's the other problems that we have still that we need to solve. And what we want to do not is just now fail over. We want to also fail over and replay for an end-to-end business continuity, right? We want to make sure that new users can come in. We want to mask some of these recoverable errors. Remember, I committed. I don't know what happened. If there is a plant maintenance, I want to make sure it's hidden in the sense that if instance one is taken down, the application doesn't even know or is unaware. We automatically reconnect and replay. In-flight work is preserved. This is the most important part of our work, which is in AC and TAC. We will talk more about 23 AI, 23 AI app continuity features. And Sebastian, I can tell you a lot of those, not a lot, some of them are backported into 19, the latest RUs, some of them. And remember, we are really trying hard to make sure that even in 19, you can benefit from it. But let's talk about it in the context of 23 AI. In 23 AI, what we want to do is better performance in terms of making sure where you left off and continue on for your application. Simple for developers. We want to give you statistics on what we can cover and what we can not cover. All right. So if you have looked at app continuity, and this has been even when I started off, why is that two things, app continuity and transparent app continuity? Well, they essentially do the similar things. They're both a flavor, one solution for either planned maintenance and unplanned outages. It's available with RAC and Active Data Guard. The difference is in their implementation because customers, your deployments, you have various types of deployments. Some customers use connection pools. Some of them don't use connection pools. Some of them have various requirements on how to do or how they want to take care of, say, side effects. And I talk about side effects. But essentially, we kind of give you two choices on how to use them, right? So in 23 AI, obviously, 40% improvement for selects and we reposition cursors. I talk about what is cursor repositioning. We also have 50% CPU cost. Remember that it's not, in the sense that when you have to maintain state for a process that has done a commit and it has failed out to other node, we also have to keep some metadata information that is taking some CPU. We have even lowered that in 23 AI with lower up to 50%, right? So these are the numbers that we have, but what the main crux of the main driver of that is what we call as transaction guard. So let me explain a bit about what is a transaction guard. So we have this problem that I explained earlier. I inserted into some table on node 1. I was connected. I inserted it. I did a commit. There was a eviction or some unplanned outage. Now there could be two choices, right? I could have either sent the commit. The commit could have gone to the log writer. It would have committed it, returned to the redo logs, and wants to come and give me a commit acknowledgement, and there was an eviction. Or it could be that before it could write to it, there's an eviction. When you fail over, the application doesn't know where it was. What happens is the crux of all this is the transaction guard, which runs behind the scenes, which is the entity responsible for making sure that the committed transaction, we resend the commit acknowledgement to the application that failed over to the other side. Or if it is not done, then we could do it and then make sure that the acknowledgement is there. So with 23 AI, we have what we call as a native transaction guard, and up to 95%, we have reduced the CPU cost. So we want to make it even simpler for developers to adopt. It should be as simple as like, hey, just I need to do some configuration changes and I'm done. And that's what we aim to do. So we do not want them to know about, hey, how do you make changes to your code? We want to make sure that they use it seamlessly. For the database side, we have concepts called draining. For draining, we basically is a way by which we nudge the session to say, hey, you're on node 1, there's a plant maintenance on node 1. Would you want to go to node 2 or node 3 or wherever? So we have this draining. What happens is we will take care of things that don't fail over, what we drain over. We can either choose to say, hey, my drain window is 2 hours, which means it increases my maintenance windows, or we could just say, hey, we could just take care of that and kill that session, or you could decide to wait for it. Now, all this can be done by the DBA. The application user doesn't need to worry. For those that can be protected, we can easily move over and TAC will take care of it. Which those we cannot, we'll have to interrupt them. Now, when we say some things obviously cannot be taken care, and we talk about what are those specific entities. One of the things that we want to make sure that when we fail over, or when a connection pool or a session goes into a connection pool and says, I want a session, is that we want to make sure that everything is wiped clean for that connection. Because remember, in a connection pool, we are constantly reusing connections. The problem was before this feature, when a connection pool is reused, certain information was still left in the pool, which could be something bad for the new session that gets that connection pool. So we had this session state and cursor. So with Oracle 23 AI, for database 23 AI, we automatically reset it. What that means is the session doesn't need to go and clean it up. It can, it already receives a cleaned up connection. This is done by the database itself. The benefit is that we prevent some security holes, and then there's a lot more coverage for things like microservices and other things. Because remember, these are the entities that take more connections and use it. So microservices-based development would take care like, hey, I would connect to the database, do my work, disconnect, do my other work, and some other entity will connect again. So the more the usage of the connection pool, the more the importance of reset state that we have. And then 23 AI, we automatically do it. It's a highly demanded customer feature because this kind of broadens our protection for different kinds of applications. Then we have this concept of resumable cursors. So look at that SQL on the right-hand side. You basically have a bunch of select for a large order. Then within that order, you do a while loop saying, hey, for everyone, I want to do a particular transaction. In this case, I fetch order number into something, then I do some transaction work. Now, what happens if there is some failure? If order IDs for that sys date -7 was 5,000, where were you in the middle? Were you in 2023 or were you in 4,999? So we did not have this capability until 23. So what we have had done in 23 AI is now we can continue where we left off. That way, we reduce the time to when the failover occurs, that we can continue off where we left off. So it's essentially a automatic feature that you benefit from, but that's because now this resumable cursors reduces the TAC discovery of request boundaries. Now, what is a request boundary? Request boundaries are, remember that when you connect to the database, you can do a lot of reads. Now, it's very easy. The problem comes when you are trying to do insert, update, delete transaction. So we need to figure out where is that and when is the commit for that. So this helps us to automatically be able to do our work in terms of detecting automatically request boundaries. So this is all like 40% faster at failover because now we can reposition customers faster, and then because of this, we can increase our TAC coverage automatically now. Then we have ensure replaces the same session state. Obviously, security is one of the big things that we have, with Oracle database. Yes, we want to do all these smart things, automatic things, but we also want to be secure. Now, remember our problem. We have a node 1, we do some work. Now we go to, we had an issue, we fail over to instance 2 or instance 3 or other instance. Now, what we want to do is we want to continue exactly as it was. In the first instance now, we had access to, say, example, the database links where there are certain, information that we use to connect to the remote site. All of this may not be deemed okay to just put it in the, to be, disclosed to other things. So we want to make sure that what we call as encrypted things are also accessible from the other side. So we have a concept called as the database template, which is a set of session states that is maintained for the database. So now, because we can use the replay uses the same session state, we don't need to go and do this callbacks for getting again this encryption credentials and doing all that again. So we can automatically do that in 23 AI, which is basically use the same session state, benefit from those encrypted credentials, making sure that the session is valid for that. All of that, we take care of it. And this is done via, if you set the failover restore to level 2 or auto. I talked a bit about customizable side effects. A customizable side effect is, typically we think of database as like, hey, everybody does insert update deletes. And unfortunately, people do a lot more. They can do like hey, I sent this insert. Now I want to send this DBMS package to call UTL HTTP, or I'm trying to write to a local file system UTL file. The bad thing is when you fail over and you're writing to something locally, it's gone. I can't continue there. So same thing with database links, right? If you are unable to reach from one side, you go to the other side. What do you want me to do? Should we be able to access that? So this is called as side effects. So with 23 AI, we give you a choice of what we call as customize your side effect, which means that instead of we failing over and saying we don't know what to do, we say, you know what? Why don't you, as the application owner, set it once and we'll take care of it? So again, for autonomous database, you have this execute DBMS app package. For servctl, if you want to do, you have your own option to do that. Essentially, you can say, hey, for service, my service, let's make it replayable true. That means this for database links, I have customized it for me. Then what we have done is in 23, we have one JDBC jar. So if you look at the 19C, you have to download a bunch of jars, make sure they're included in your class path. Now you have one, including the one where if you have a debugging or something needed, the OJDBC debug jar also is included. So you don't need to like say, okay, now I have a problem. I have to go and change my data source. I need to go and change. No, you got one and you're done. And the link there is done. So it makes it easier for database developers to basically consume AC. Now, in the autonomous cloud, we don't have access to the host. So application owners can decide like, hey, I think I want to use AC for certain things. Like, okay, then you can use the DBMS AppConf package to set these things. Obviously, with servctl also can be done for all those deployments that are done in the on premises or on the Exadata or DBCS services you have. Depending on, regardless of your regardless of your application server, we are covered. We used to have, until recently, the biggest problem with what we call a Spring Boot or Hikari. Well, we have now a solution for that. With Tomcat, we have solutions for that in the sense that what to do. And with JBoss, obviously, we have been working for a long time on that. But Spring Boot is a special one. So if you now go to the Spring Boot, you can see that now we have connection boundaries. That is now Hikari can automatically take care of it. So essentially, before this feature, Hikari did not have or support for connection boundaries. Now it can do it. So this really helps us AC work automatically. So if you are on the I would say the latest, it was released, I think, in November with the latest Hikari. So if you download any Spring Boot with Hikari since November, you should have support for it. So that means we have taken care of all our Spring Boot customers. For JBoss, you want to make sure that the specific data source are set up. I've highlighted it in yellow. You should be able to use it. Now, let's say you have done all your configuration, your database is set up, your application is set up. Now you still may want to know that, hey, I want to know if my application is protected or not. I have 1,000 applications. I don't want to just enable it. I want to see how it is. Well, we make it easier for you. If you look at your AWR report, we actually provide you statistics to show you whether your transactions that you're using or the type of transactions you're using, the way you're using, whether they're protected or not. So if you look at it, you basically look at these sections, the cumulative begin request, the cumulative end request, protected by app continuity. As long as these numbers are almost close, you're good. What that means is almost close, which means that let's say you have 5 million protected and 1 less, like 4,999 is protected, 1 is not. It means that other than that 1, all of your things will benefit from app continuity. So that's the way to look at it. It doesn't have to be exact, right? Now, let's say you find out something is bad. Now, what do you do? Well, you have a choice. You can find out what is that problem. So in this case, when you run an AC check, we will tell you that, hey, something I couldn't protect because, and then it gives an error code. If you look at an OERR for that error code, it will tell you what you're doing wrong in that. So that you can go and look at and say, oh, I'm having maybe something that is not AC. AC cannot, protect it. So what can I do on that? So yes, there may be sometimes you can make some code change to get benefit from that. We expect this to be reduced a lot as we get into covering more and more cases. But yes, there are still some ways by which an application is written such that we may not be able to replay it. And that's the then you have to make the change. Right. You can also get detailed filtering of AC checks. So if you get a lot of data, you can say, hey, I want to just get it for service 1, service 2, whatever. Automatically, we can make sure that, we want to make sure that, hey, what is your drain timeout? Now, what we have done in 23 AI is we say, hey, we actually tell you via histograms that less than X number of seconds buckets, these are the number of sessions that failed, drained without, within that bucket window. So this gives you an idea on what to set when you set your drain timeout. Remember, you can do service modify service, and you can set a default drain timeout. And how do you get a good default drain timeout? Use this view to get an idea of what is a good number so that you can cover your different database maintenance windows. Right. Understand your protection level, right? So when you add a service, obviously you don't want to, you might have existing services, you could say service modify service, but what you want to make sure is certain things like for load balancing, the preferred, for app continuity, these are the settings that you want to do. You understood your protection level, you looked at AC check, you looked at, and then you go to your database and your specific service and you figured out this is my protection level because based on the data I have that I looked at, this is what will work. This is the drain timeout I can set. Remember, we can set, hey, my drain timeout is 300 because in my buckets, in that $V view, I saw that 300 is the number by which all my sessions or 99% of my sessions fail over. Okay. And when you said notification equal to true, that means you get the fan ONS for your OCI. And then obviously when you have end-to-end protection with your primary and standby. And if you have standby, use the role-based services using data guard. You want to make sure you use the recommended connect string. Sorry, I just went a little bit further fast there. But essentially, the highlight I want to point out is remember now that you can actually specify that in milliseconds. World is getting much more faster, right? Nobody wants to wait for seconds and seconds. So now we actually set you for milliseconds. Depending on your network, this may be really good or not. Again, these are good numbers to start with, and you can tune them as needed. You want to make sure that you have fast fan is correctly configured. Remember in the earlier slide, I said the ONS needs to be getting that information about changes in the database or infrastructure to be sent out, you want to make sure that your port 6200 needs to be open. So many times I receive this question that, hey, my fan is not working. And it's mostly because in this new world where all the ports are by default disabled, you need to enable 1521 or whatever is your listener port, and you want to make sure your 6200 port is open. That way the events can flow to the application, right? Now it's Anil, you give us so much information. Where is this documented? Well, good. We have documented this in the MAA guide, and you can look at this. A lot of the things that I talked about is already there, so you can get into a lot more details. Now I'd say, okay, great, Anil, this is all good. Now, how can you test app continuity? Well, this is where our live labs come in, right? If you go to the live lab, and there are a lot more links about different live labs, you could actually run it on our tenancy, or you can run it on your tenancy. You can go through all this. You can actually take your sample program. Some people try Swing Bench. I would recommend that you download the latest one. Don't try SQL Plus. This is something that I keep saying. People try to do SQL Plus and say DBMS, something. No, that's the one way you don't want to do it. Use Swing Bench or use your own Java program. Run this through the lab. By default, you get 4 hours. You can increase it to 8 hours if you want to, or you can run it on your own tenancy. And this is just one lab. The fundamentals of app continuity. You can even get into the other 3 labs that Osama mentioned, and you can play around with this in a controlled environment. And with that, I want to come to a stop here. The idea is, again, RAC provides the #1 choice for scalability and availability. The idea is we don't want to go down, neither for this database side, neither for the database infrastructure, but also for the app tier, so that you as a customer don't see any downtime for any of your applications. And with that, I want to conclude. I hope I finished. I think I did decent in terms of time. Yep.
Yeah, we are good in terms of time. Thanks, Anil.
Perfect. And so, any questions that I think Sebastian or somebody that I need to answer?
Yeah.
Go ahead.
Hi, Anil. Yeah, there are 2 questions essentially. So one of the questions has been for the GI patch rolling update part, which you showed on 23AI. There is a capability already in 19C to do the same. So where are the enhancements over what we have in 19C, which, if I remember correctly, was backported something with 1916 or something like that, where we already introduced that GI rolling patching without downtime?
Excellent question. Yes. So I think I mentioned this. Maybe I went through it a bit fast. So one of the biggest problems of rolling patching, and I'm guessing you meant by zero downtime grid infrastructure patching.
Yes, that is the question.
Is that in 19C we had this feature, and just to explain the complexity, right? You're patching the GI for the database while the database is up and running. What does the database need is constant heartbeats with the CSS, right? Now we have an infrastructure to take care of it. The CSS also does what is called as the group membership services. I've talked about group membership services in the past. So CSS has 2 functions: node membership services, which is essentially the health of the nodes of the cluster, and group membership services. When during the time of patching, if any database requires any group membership changes, and there is a discrepancy in the nodes between the group membership, we used to have to take the entire infrastructure down, because now we don't know what happened. Now, again, these are corner cases, rare cases, because most of the time the peer information of group services is synced up. What that means is, if a database says, hey, I want to create this group, and we give that this group, we try to give that group membership services to that entity, and then we send it to the other node saying, hey, I'm having this group membership services for this group. Do not allow another user from another database to create a same this group name or whatever. Then we send it out. Now, sometimes the other database The other CSS may get this information most of the time, obviously, but sometimes it cannot. Now, what happens is there's a sync up, and sync up happens, and it's much easier to do a sync up in 23 than 19, because remember that ONMD and CSSD are split. Now, ONMD is very keen on just doing a node membership. CSSD, we can wait. We don't have to wait for this peer information of group membership being synced up to be impacting your node membership. So in 23 AI, just for the fact that these entities are separated out, you have a lot more coverage in terms of patches that could be applied without having to take or resort to a instance down or a crash at that time. And that's one of the biggest things that we have seen is when you take your instance, GI down for patching, you're really not supposed to do a lot of the transactional work like creating this group, creating other things. You're supposed to use it as a quick thing to apply the GI patch and move on. But what we have noticed is these things happen and you can't prevent it. But in 23 AI, your coverage will be a lot more. So in 23, that is one of the things you will have a lot more coverage than in 19 because of that change. I hope I answered that question.
Thanks. Another question. So when you went over application continuity, the reset state, and there was a question if you do know with what patch level that will be backported to 19C. I could see that the parameter exists on the service level, so there was the idea to backport it, but I haven't seen any backport happening right now. Do you have any information if reset state will be backported, and do you happen to know the release when this will appear?
Okay, this is when I put my product manager hat, because the developer and Sebastian and I work with her a lot. The developer for AC is one of the most enthusiastic person that I've seen in my entire life, and I've been in Oracle for more than 25 years. To backport things to previous releases, because she completely understands the real world that customers want to use 19C. So I would say it should be out way sooner, and I can't say specifically when. So what's stopping it is essentially there are certain changes that goes into RUs. The RU, as customers agree, we need it to be as stable as possible. So we don't put every fix there unless it's deemed very, very highly required for certain customers, or this is coming as a request from certain customers, and this is supposed to be stable enough that it won't impact the RU. So these three conditions are important. So if you have a customer and you really, really need to use the reset state, reach out to me or Sebastian. You know how to reach out, and we will work with you, because we have the other two things. We have a stable change. We just don't have enough justification to put that in, as far as I know. So that is my answer. So please reach out to either of us, and we will help you to figure out, and then we can maybe make your case as justification to get it in. And again, it's just a very complicated answer, because it's not that RUs we can put anything we want.
So as Anil pointed out, we do have a few features which were backported or which are in the process of being backported, like the capability to enable database links. That is what it's checked at the moment. So reset state is not yet backported. It could be if there's a high enough customer demand. So please raise an enhancement request with sufficient business case, and then I bet that we get this backported for you.
Right. And again, as I said, feel free to contact us. If you're working on AC, I would really like to know about your use case with AC. Hey, maybe it works. Maybe there are some issues. Yes, we can work together. Sebastian and I are very keen to get, help customers with AC, or their deployment of AC. Okay. I think there's another question.
Yeah, there was one other interesting question which Stefan already partially answered. Do you know about the efforts of getting AC TAC supported for EBS? e-business suite. So normally I would say, please ask the EBS product manager, because that is essentially their field. But yeah, we are involved at that as well. Maybe you have some more information on the progress there for AC and TAC with EBS.
Right. And I think we answered this a little bit earlier, in the sense that a lot of the changes in 23 are geared towards increasing coverage. The problem with specialized application packages like EBIS is there is some concurrent manager usage which uses a lot more of OCI, and as I mentioned, there's a lot more coverage for OCI and lesser CPU usage and all that. It's a work in progress. Is the coverage 100%? No, not yet. Is it going to get better? Yes. Again, as I said, if you have a very good case, we are happy to work together. It may not give you 100% coverage, but it could give you certain protection. Again, the HA levels, as I described, there are 3 levels. Maybe you get level 1 for now, or maybe you get level 1 and 2, depending on your stack. It's a very, open question. The more current your version number for your database RU, the more current your app server version, the more current your application, as in the EBIS version, coverage is better. But I would answer this in a better way, that with 23, this will be a lot more easier for all of these apps to consume. But that's pretty much all I have. We don't yet have like 100% coverage for EBIS at this time. Like, Sebastian, you want to add anything more on that?
No. There's one more question, which I'm not sure if that is really covered with RAC. Any new features introduced in 23i for monitoring, alert, or performance, same like OEM monitoring? But
yes,
I mean, that is not directly a RAC question, except if you talk about our autonomous health framework. So maybe you can enlighten there a little bit. But other than that, I'm not sure how to answer this question.
Yes. So I'll answer it in 2 ways, right? So OEM or enterprise manager monitoring, yes, they consume a lot of the newer weight events that we have. Remember, AWR itself is changing, and AWR is actually an EM part. So we are actually making a lot of changes to AWR to help you understand the performance problem. As I told my developer, that AWR is now like a dump of end minus begin, and we order it. We don't order it in any order. We want to make sure the problems are in the top. I mean, we want to make it more easier for customers. So AWR is one way by which I would say monitoring is better. All the weight events are there. And remember, in 23 AI, we have ways by which you can get our statistics, expose it into some Grafana dashboard that you have custom built. All of that you still continue to have. That is one part of the EM part. Then we have something called not EM. We have something called insights. Now, if you have not heard about insights, my good friend Sandesh is going to come and talk to you about it, but I can talk about it too. But essentially, insights is this new thing by which you can collate and correlate different what we call as signals and come up with a conclusion. So this is another amazing thing that you have. You could actually download it for free even right now and use it with 19 and 23 and see what are the automated things that it benefits from. Remember, it's a two-way street, right? The database generates these events, and the tool, either it's EM or Insights, uses that and creates what we call as a dashboard or for you. And so both of these things are available. So with 23, you will again get more of these information, and which Insights or EM can use to give you a better idea of what's the state of your entire infrastructure end to end. Does that make sense?
To me, yes.
Yes. Cool.
Not sure if it makes sense to the one who posed the question. So hopefully it answers it.
And as usual, if there are more questions or sub questions on that, I keep saying, reach out to me. I usually respond to LinkedIn and Twitter or within a day. So yeah, let me know. All right, if there are no more questions.
That were all questions.
Perfect. Once again, thank you so much, all of you guys for having me. Hope it was useful. This is recorded. If you have questions, as I keep saying, come back to us. We are happy to work with you.
Yeah, thanks a lot, Anil, for this deep dive presentation, and thanks to our panelists, Sebastian, and also for the answering the questions, all the questions that we've had in the chat, and also for Stefan. So thanks again, and goodbye.